to another lesson on our series. Today we are looking at indefinite algebraic integrals. But before we go into that, let's revise on what we did in our previous lesson. We said that given the integral small f at x dx to evaluate, we want to find capital F at x whose derivative with respect to x is small f at x. That is, when we have the derivative of big F at x, it gives us small f at x. So this implies that the integral of small f at x, which is the derivative of the big F at x dx, produce big F at x plus a constant c. So this simply means anytime we differentiate a particular function, say small f at x dx, it tends to give us another function plus a constant. So let's look at the various parts of what I've just written. This symbol is termed as integration symbol. Now the small f at x over here is named integrand. And now somebody may ask, what is the meaning of the dx? This dx is the variable of integration, and of course this is our antiderivative. And now lastly, our constants of integration. Let's look at some of the basic indefinite algebraic integrals. Example 1. Our first example says evaluate the integral of x power 6 plus x power 4 plus x dx. Solution. We are given the integral of x power 6 plus x power 4 plus x dx. First of all, let's apply the integration symbol and then variable of integration to all the terms over here. And with that, we're going to get x power 6 dx plus integral of x power 4 dx plus integral of x dx. Now let's integrate. We are going to get x power 6 plus 1 divided by the power 6 plus 1 plus x power 4 plus 1 on 4 plus 1 plus x power 1 plus 1 on 1 plus 1 plus our constant of integration. So we are going to get x power 7 on 7 plus x power 5 on 5 plus x power 2 on 2 plus c. And that is our solution for the first problem. Our second problem, says evaluate the integral of x power 5 plus x power 3 plus x plus 2 all on root x dx. Solution. Integrating this, we need to break the expression down by dividing each of the terms at the numerator by root x. Then after the simplification, we integrate. So let's look at it. So we are going to get the integral of x power 5 on root x dx plus integral of x power 3 on root x dx plus integral of x on root x dx plus integral of 2 on root x dx. So at this very stage, let's simplify. In simplifying, you can see that the root x over here also simply means x power half. Then from law of indices, they have a common base, so you can subtract the powers. So with that, we're going to get integral of x power 5 minus half dx plus integral of x power 3 minus half dx plus integral of x power 1 minus half dx plus integral of 2x power negative half dx. Let's simplify the powers, and that we're going to get x power 9 on 2 dx plus integral of x power 5 on 2 dx plus integral of x power half dx plus integral of 2x power negative half dx. After we are done with all those algebraic manipulations, now it's time for us to integrate. So integrating, when we add 1 to 9 on 2, we are getting 11 on 2. Then we divide by 11 on 2, which is the same as 2 on 11. Plus, when we add 1 to 5 on 2, it gives us 7 on 2. So it means we're going to get 2 on 7 x power on 2. Plus, when you add 1 to half, that is power 3 on 2 by 2 on 3. Plus, when you add 1 to negative half, it gives us x power half by 4 plus the constant c, and hence our solution. The next example says evaluate 1 on x dx. Solution. We're given integral of 1 on x dx. In integrating this, one might say that we need to convert this one to the power form, and then we add 1 to it and divide by the same thing, which you can see clearly that it will lead to x power 0 on 0, which is undefined. So how do we integrate this? We need to do some revision on basic differentiation. From basic differentiation, you learned that when we have y equals a ln of x, this is the same as having a log of the base e x. When we have a logarithmic function and we want to differentiate, y prime will become 1 on the function x by finding the length of the base, then e. Then you multiply the whole thing by differential of the function over there, and that is differential of x, and that is what? 1. And when we simplify that, we are going to get 1 on x, ln e is 1, and then 1 by 1 is the same thing, so hence we are going to get y prime is equal to 1 on x. So this simply means that the differential of ln x is 1 on x, and we know that the reverse form of differentiation is integration. So this implies that if you have an integral of 1 on x dx, it simply gives us a ln of x. But here we need to put it into absolute value, because you might not necessarily know that this is negative value or positive value. So this cater for every value. So the integral of 1 on that is this. Please take note. With this idea, let's look at our next example. Example 4. This integral of x power 3 minus 2x minus 7 all on x dx. We are going to get integral of x cube on x dx plus integral of 2x on x dx plus integral of minus 7 on x dx. Simplifying, we are getting integral of x squared dx plus integral of 2 dx plus integral of minus 7 on x dx symbol, and that gives us so integrating x squared, that gives us 1 on 3 x cube plus integrating 2 integral of the x, we are getting 2x, then minus 7. Then we know the integral of 1 on x is ln x. plus c. We should evaluate integral of x squared plus 1 on x all squared dx. In integrating this, that will be x squared plus 1 all squared on x squared. With this, expand the numerator, we will get x squared times x squared, that is x power 4. 2 of the product of x squared and 1 will give us 2x squared. 1 squared, that will give us what? 1. All on x squared dx. Breaking it down, we are going to get x power 2 plus 2 plus 1 on x squared dx. Give us integral of x squared dx plus 2 integral of dx plus integral of x power negative 2 dx. Now integrating, this gives us 1 on 3x cubed plus 2x minus, when you add 1 to this, we're going to get a negative, so x power negative 1 divided by that, and that gives us this plus c. We can rewrite this one well. 1 on 3x cubed plus 2x minus 1 on x plus c. And that is that. They say we should evaluate root x plus 1 all squared. So as usual, we need to expand this. Expanding, we are getting integral of, we need to square this, and that is x. 2 times the product of this and that gives us 2 root x 1 squared, that is still 1 dx. Integrating, we are going to get x squared on 2 plus our 2 half plus the 1 half plus 1 x plus c. So simplifying, that gives us 1 on 2 x squared plus 4 on 3 x power 3 on 2 plus x plus c, and that is that.